Hello class, it's Sir Christian here. So for today's lecture, we will be learning about doing additions in binary, also subtractions, and we'll also do ones and twos complements. So stay tuned. So okay, now we have the lecture for today. So we have these topics again. So that's binary addition, ones complement, twos complement, binary subtraction for this slide. Okay. So binary addition, it's just simply adding binary numbers in very simple tasks. So it's similar to longhand addition of decimal numbers. So again, it's base 10. However, still follows two state ones and zeros rule of binary. Okay. And adding a high level bit with another high level bit will result to a carry in bit placement. Okay, so again, as we go along to this, we'll know how to do this. So it's like this in binary. So again, if we add 0 and 0, so the sum is 0. If it's 0 and 1, that's 1. If that's 1 and 0, so that's 1 still. And if it's 1 and 1, it becomes 0. And there will be a carry for this. Okay. So with this lecture, we'll have examples here in this slide. So yeah. I hope you understand this. And right after we do the kind of complicated method, so there's also a simpler method if you want to add or subtract binary. Okay. So here are some examples. So let's do this one, the first one. So let's do it. So that is, let's just type it 1 0 0 1 1. So let's just put a space on top and then at the bottom, so let's add it to 1 1 0 1 0. So again, this is a typo error from the book, but the answer of this, so this one, its equivalent in decimal is 19. This one's equivalent in decimal is 26, so the answer is 45, but this binary number here doesn't show 45. So let's try solving this one. Okay, so here we go. So when we add binary, this is how we do it. Okay, so okay, so one plus zero again is equivalent to one. So that's equivalent to one. Okay, so now here we go. So the one and one. So in binary again, one and one is equal to zero, and it needs to be carried to one. So again, the result for one and one is equals to 10. Okay, so remember that one. That's why there's a carry. So we need to carry this one here. Okay, so let's do this. So 1 1 is 10. So let's put 0 here. And let's carry 1 on top. Okay, so let's make this small. Okay, anyway, that's 1. So 0 plus 0, so we need to add 0 first. The So the answer of that is 0, as we know. And then we have a carry 1, so that's why we put 1 here. The next 0 plus 1 is equals to 1. And again here we have another example. So 1 plus 1 is 1 0. So the answer on that example must be 1 0 1 1 0 1. So again, how do we check if we are correct? So let's use the programming calculator. Okay, program calculators, you can see. So again, it's here on the side. Now let's double check if we are really correct. So again, that's 1 0 0 1 1, and we'll add it to 1 1 0 1 0. So the answer is 1 0 1 1 0 1. So that should be the answer on this portion. Okay, so that's just it. So if we convert it, so that is 45 in decimal to the in hex, and in octal that's 55. Okay, so just a recap. So how do we convert it to decimal? So again, you just add the bits one by one. Okay. So again, just a recap. Let's do it for you. So how do we convert it to first? We need to convert it to decimal. Okay. So again, there is a table here. Don't forget this. So it starts with 1, 2, 4, 8, and 16, so on and so forth. 16, 32, 64, then 1 to 8, okay, so on and so forth. So it's just 1 plus 1, 2, 2 plus 2, 4, 4 plus 4, 8, 8 plus 8, 16, so on, so on. Okay, so now let's convert this to decimal. So what does this stand for in decimal? So this is 1. So what does this stand in binary? So this one is 4 and this one is 8. So they are on 4 and 8. And then this one is 16 and this one is 32. So we just add up all of these. So that is 32 plus 4 plus 8 plus 1. So the decimal now for this is now 45. So let's just put an illustration here. So next time I'll find better tools. So have a like classroom blackboard. So the decimal for this is 45. So now we want to convert this to hexadecimal. So again, remember that we have a table again for hexadecimal. So hexadecimal table is just search for that online. So again, we have this from 0 to F. Okay, this one. So let's just use this as our guide. Okay, so now we want to convert it to decimal. So again, how do we convert it to decimal? So again, as you can see, there should be 45. So decimal should be hexadecimal should be 2D. So how do we get that? So again, for hexadecimal, so we have this binary. So let's do it. So this is just a recap, guys. 0010, so 1101. So again, this is a good practice that you separate them into 4 bits. Okay. So in case yung parang malilito kayo, like may tawag nito. Kung sa Bisaya malipat kayo ba? So that this is a good practice. So even though the bits are not turned on, so just put zeros in there. Okay, so let's try to convert it to hexadecimal. So again, the easy way is let's divide them into 4 bits. So 4, yan. And now, after that, let's just convert them directly to decimal. Let's convert each decimal. So this one is 1101. So what is the decimal equivalent for this? So I think this one is 13. 13. And this one is 2. Okay, so now we'll look at the table. So we have the table on the right. Okay, so what is the equivalent of 13 on the table? So it's D. Okay, D. So this side is D. And the equivalent of the other one is 2. It's still 2. So that's why we have the answer 2D. Okay, so as you can see in the calculator, it's 2D. Okay, so now again, how do we convert it to octal? So we need to have 50 answer 55. So just similar on how we converted it to hexadecimal. So just similar, it's just 00 10 11 01, but this time we need to divide them into 3 bits. So like that and that. Okay. So what is this in binary? So this one is 5 and this one is 5. So the octal for this is 55. Okay, yeah, so this is it. Okay, now going back. Anyway, what if you want to convert from octal to like hexadecimal? So the easiest way for that is, for example, we have 55 as octal, you convert it to binary first. Yes, and then after converting it to binary, you execute this easy method. So yeah, that's it. Same goes for hexadecimal. You convert it first to binary. You're using our method. And yeah, that's how you can convert them easily all in all. Okay, so now let's go back to the binary addition. Okay, so now let's do the second example. So this one here is okay, so this one is 1011 0110, and then next is 1101 1010. Why this 1011? Okay, so let's add this one. Okay, now let's go. So 0 plus 1. So again, that is 1, 1, 1. So again, that's 1, 0, 0, carry 1. 1 plus 0 is 1, plus 1, 1, 0. So 0, carry 1. So 0 plus 1 is 1, plus 1, so 1, 0. So remember that 1 and 1, 1 plus 1 here is equals to 1, 0. So again, we have another 0 here. Then we have to carry it again. So 1 plus 1 is 1, 0. Okay, so it is 0 here, it should be. And then, but there's a carry, so we need to put 1. And then carry 1. Okay, in case you're wondering here, bakit 1 pa rin? So ito yung mangyari. So 1 plus 1 is equals to 1, 0, di ba? So itong 1, this will be carried over to the next. But meron siyang carry 1 ulit. So 0 plus 1 is 1. So kaya naging 1. Okay, so 1 plus 0 is 1 plus 1, 0, 1, 0. So this one is again is 0, carry 1. So 1 plus 0 is 1. So 1 plus 1, 1, 0. Yeah, 0 ulit. So again, carry ulit 1. So again, 1 plus 1 is 1, 0. So 1 plus 0, so 1. And then, yung may carry over na naman dito sa taas na 1, di ba? So, ito yung nasa ilalim. So, so this is the answer. So, 1, 1, 0, 0, 1, 0, 0, 1, 1. So, ganun lang guys. Ganyan lang. Kaya nyo. Okay, so now I want you to do the last example on your own. Okay. So, alam mo kung kayang-kaya nito. So, do it on your own and I hope you get it. So here next we have the ones complement. So it's just basically obtained by inverting all bit placement values. So we have the table here. So ibig sabihin pinabaliktad lang natin yung value niya. So we have the table here. So binary 000 maging 1111. 0001, we have 1110. Okay? So, bali, ibali-baliktad niya lang. So, kayang-kaya nito. Napakadali lang. So, we have some examples here. So, I'll do the first ones for you. So, ito. It's snipping tool na lang natin. Diskarte tayo. Ayan. So, we have this. Paano ba mapagana natin? Okay. Here's the paint. Okay. Okay, so let's say we have this example. So, pag one's complement, remember na ibabaliktad lang natin siya. So, we have 1, 0, 1, 1, 1, 1. So, basically, babaliktad lang nga. So, 0, 1, 0, 0, 0, 1, 0, 1. Yun lang. Yun yung one's complement. Ito naman is 0, 0, 0, 1, 0, 1, 1, 0. This one is 0, 0, 1, 0, 1. Okay, so the rest, I want you to do this. Okay, so that's it. Babaliktad lang. Okay, kaya nyo. So now here, let's go to the two's complement. So there's just two basic steps into solving the two's complements. So first step is we need to convert this one first to one's complement, and after that, we just add one. So now let's try solving this. Okay, so in this example, so the two's complement of 1010 is 0110. So now let's solve this here. 1010. So let's convert this one. So the first step here is step 1. Convert to ones complement. Okay. So again, how do we solve ones complement? So we just invert all of it. So let's invert this to 0101. Okay. So step 2. Add by 1. So again, so how do we add 1? So again, so if you add 1, so this one is 0101. So if you add 1 here, it will become 10. So carry 1 here on top on this. So the answer is 0110. So that's just how we get the two's complement. So yes, you can see the answer is 0110. So now let's try getting the two's complement of the following example. So I'll do the first parts for you, and then the rest you do it on your own. So now we have this. So again, let's first convert it to one's complement. So the one's complement of this is just invert all of it. So this is 0, 0, 0, 0, then 1, 0, 1, 0. So let's add it by 1 again, add by 1, so this becomes 1. Second one is, first again, convert it to one's complement, so that's 0, 1, 0, 1, 0, 1. Okay. So again, so we add it by 1, so it becomes 1, 0. And this one, so 0, 1, 1. So we I mean, one's complement, so this one is 0, 0. So just add 1 again. So that's it. So that's how we get the two's complement. So now let's go to the binary subtraction. So it's just similar in what we did in the addition. So here are the steps. So subtraction of two binary numerals involves adding the minuend and the two's complement of the subtrahend. And after adding the two, the leftmost bit placement is discarded. Thus, we arrive at the difference. So let's see this example. So again, the minuend So this is the minuend and this is the subtrahend. Okay. So in subtrahend we need to get the 2's complement in. Let's just add it, and this is the outcome. So let's try doing this one. So okay, so this is what we're gonna do. So this one is 1010. So it's 2's complement of, again, so we need to get the 2's complement. So now the 2's complement is, again, first we get the 1's complement, then we add out 1 for it from it. So that is 1 1. So first we get the 1's complement, so that's 1100, and then we add 1, so that's 1. Okay, so now let's add this. So again, don't forget how do we add this. So this one, 0 plus 1 is 1, 1 plus 0 is 1, 0 plus 1 is 1, and 1 and 1 is 0 1 1 0. So that is the answer. Okay, so now we need to discard the leftmost bit placement. Okay, so we need to discard this one. So the answer here is 0 1 1 1 1. Okay, so that's just how we subtract using binary. Okay, so again, thank you. Thank you for listening for this lecture. And now you do the activities based here. Yeah, there's some exercises and I hope you practice. Okay, so again, that's it for our first video. So thank you for listening. Hope you enjoy it and hope you learned a lot. Thank you.